Everybody, let me start with the fact that this discussion of the unit circle is in homage, of course, to Khan Academy, Sal Khan and Rockstar Team, and JMT Patrick, and with a little bit of shout out and mention to Elvis Zapp, Professor Elvis Zapp. And let's not, of course, forget Khalid at betterexplain.com. And y'all are doing great stuff, but you missed this one. So I'm going to now show a drafting of the unit circle. And again, I can't draft a circle, but the unit circle centered at 0, 0 with a radius of 1 has these unique properties for its coordinates. Khalid will tell you that every circle is just the unit circle made bigger or smaller. Well, of course, you know what those are going to be, but what you can do is you can now draft a line splitting this, and draft a line splitting that. And in the end, then you know that that is going to be 30 degrees, 45 degrees, and 60 degrees. What you're missing here, and what it's always been missing, is in fact 15 degrees. And we're going to come to that in a little bit. The reason why people don't teach the values at 15 degrees is in fact because it's not convenient. Well, let's make it convenient by finding another number pattern. Let's, of course, remember I'm going to use degrees here, though in reality we're supposed to catch our brains to realize that this is an angle of 2 pi, which makes this an angle of pi, which makes this an angle of pi over 2, which makes 15 degrees the same as pi over 12, but more importantly, how far the sky moves in 1 hour. The sun, the earth about its axis. So here's the number pattern. We open this up and remember that we're going to be using the circle, the coordinates on the circle, and so this is 1 in the x and 0 in the y, and this is 0 in the x and 1 in the y. And we remember that if we do these, those values are also the cosine of the angle and the sine of the angle. We now then open up parentheses for the 60, we open up parentheses for the 30, and we open up parentheses, for the 45 and for the 30. We comma, 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 chameleon. The number pattern emerges as this: over 2, over 2, over 2, over 2, over 2, over 2, 1, 2, 3, 1, 2, 3. The square root of 1 is 1. The square root of 2, the square root of 3. The square root of 1 is 1. The square root of 2, the square root of 3. I would tell you it's a nice idea, even though you know the definition of tangent is sine over cosine, to realize that the tangent of 45 is 1. You know that the tangent of 60 has got to be greater than 1. It's the square root of 3. And the tangent of 30 is less than 1. It's 1 over the square root of 3. Now let's get to the 15 degrees and look at the number of pattern that emerges. This here is best practice. It teaches you, in effect, the first quadrant, which then can be flipped and flipped and flipped, or flipped and flipped to get you the other two quadrants. But you've left out kind of the most important general concept, I would guess, that you can kind of get, is the how far does the world move in 1 hour, or more importantly, how many time zones are there? There are 24, because the world of 360 degrees divided up into 24 is 15 degrees, or pi over 12. So what does the number pattern look for there? And I'm going to put it down here. In this case, the number pattern looks like this: 2, 4, 6, and 2, 4, 6. So that the cosine of 15 degrees is the square root of 6 plus the square root of 2 all over 4, and the sine is the square root of 6 minus the square root of 2 all over 4. And for an approximate value to tangent, you could realize that the tangent is about the same as the angle, though in reality you could do it again, sine over cosine. So that is my first one-off, and what that eventually gets you to is the fact that you really don't want to memorize the circle beyond anything more than you need to, and that means that you memorize just the first 45 degrees. And those values then become decimal when you're really trying to really start to interpret and understand numbers. You do the radicals to teach the kids, and then immediately you start to learn some values here. And so those numbers, I will just put them down for, I'll move actually down here a little bit and finish that out. I'm going to say the sine and the cosine only of 45 degrees, 30 degrees, and 15, and 0. The sine of 45 is 0.7071. The cosine is 0.7071. The sine, if you look at it, of 30 degrees is, of course, I'm sorry, doing this wrong. I should always show first probably the cosine, because people think of x and y and cosine and sine. Of 30 degrees is indeed the x. The x is more than the y. It is 0.866 with a little bit more out in front, remember, and then 0.5, and then for 15 it's more in the x. It's 0.9659, and then 0.2588, and then a trend of 1 and 0 here. These are not linear, but once you know the first half of the first quadrant, you can use some other rules to get an approximate angle on anything in the circle, and that of course allows you to start using it not as a black box, but as a tool you really understand. So let's finally just talk about where this number pattern comes from. It comes from the half angle theorem, which says this: the cosine of theta over 2 is the square root of 1 plus the cosine of theta all over 2, and the sine of theta over 2 is 1 minus the cosine of theta all over 2, and that's in fact how you end up with this value for 15 degrees. That's a rough cut. We're going to clean it up and get that out so you can start to extend out, that we get the whole planet, not just knowing that there are 24 hours in a day and about 24 standard time zones in the world. There's some issue with Pakistan and Iran and Iraq can't agree, and a few others, but this general bit here, that if you know things in here, you can start to learn trends and whatever else. So to finish out the 10 minutes, I'm going to now go to a new page and just brainstorm, and without even giving you links until we put them in later. Let's see what I'm doing here. I am using Smooth Draw for this because Sal Khan uses Smooth Draw. So you got to remember that to really get that trick deep in your head, you got to find the midnight math tutor guy. All right? He's got an error here or there, but it is cool stuff. You got to find JMT Patrick out on the web. You've got to find, of course, Khan Academy out on the web. You got to find Walter Lewin at MIT, who will show you the wonders and the value of the small angle approximations. 1, 2, 3. You gotta find eventually Professor Elvis Zapp, who will do the calculus rap for you, and a whole lot more. And you've got to learn that the sine and the cosine wave, if that's the way they're drawn, is not a mystery. It's just a circle. You'll see that out at Wikipedia. Get smart fast.